How often? How often it occur in a year? So let's go ahead and summarize this. A stands for what?
Amount of things.
The amount after how many years? After T years. P stands for the principal, also called the starting amount. 1 is always 1. R is the rate, right? Now, if I say 15%, what's the rate?
0.15.
0.15. What about 8%?
0.08.
0.08. N represent what? How often in a year? T represent the time, of course. So if I say annually, how often does it happen in a year? Once. What about monthly?
12.
12 times. What about quarterly? 4 times. Quarterly is 4 times. Bi-weekly is 2 times in.
36. Isn't it 36? Yes, 36.
How many weeks in a year?
52.
How many weeks in a year?
52. 52.
How many days in a year?
Right on, boy.
I'll say 365.
Except for leap year.
365. Bi-weekly,
It's 36.
it will be every 2 weeks, which is
30. Isn't it? No, that's not 36.
26.
I was close.
Bi-weekly is every 2 weeks. Who get paid bi-weekly here? If you work. That means you get paid every 2 weeks, right? Who get paid weekly? Who get paid monthly here?
Teachers?
That's unfortunately us.
Wait,
Actually,
so did they pay you good?
alright, let's talk about financial growth and decay. Now, when I'm talking about I invest a certain amount, let's say I invest $5, that pays 2% continuously. Which formula do you think I should use?
Good one.
The daily.
I will use this one. This one is compounded continuously. How do you know which one to use? The one that does not tell you bi-weekly, monthly, it doesn't tell you how often it occurs. So if I say it pays 3% continuously, I'm not telling you how many times in a year you will compound it, right? Therefore, you use this formula. And note that there's no end involved because you don't know how often it is constantly happening. Like that's the bacteria growth. You don't know how many bacteria, maybe it doubles every hour. So instead of it will be 2 to the power of. If it reduced by half, it will be 1/2 to the power of, and so on. Now, let's look at the first problem. The first problem says, Freddie, saving account has a balance of $2,500. We need to hang out more often, Freddie. If you have that much money, just to spare. If he has not made a withdrawn or deposited any money since opening the account, how long will it take Freddie account to reach a balance of $8,000 if the account pays an annual interest of 9.5% compounded? Now, if I stop here, it's not enough. I need to know if it's continuously, quarterly, and so on, right? But here A says is quarterly. Once you read quarterly, what comes in mind? N is equal to 4. Now, which formula will I use? The first or the second?
First.
The first. And what am I looking for?
Number will be 800.
What am I looking for? The time. Now, let's break it down. The 2,500 represent what?
The P.
It represents the principal. And the 8,000 represents
A.
A, meaning the amount you get after T years. Now, let's figure out what that T is. All right, to find T, I will go ahead and set up the equation. And I will say 8,000, which is A, is equal to P, which is 2,500. Open a parenthesis, 1 plus. The rate here is what? 0.095 over what? Over 4 to the power of 4t. You understand the formula? I'm going based on the original formula we had. So what would be the first step to do? The parentheses. I will combine what's inside the parentheses, and in the meantime, I will divide both sides by 2,500. So go ahead and divide by 2,500. What's 8,000 divided by 2,500?
3.2.
So you will say 3.2 is equal to, what's 1 plus 0.095 over 4? 1.024? 1.024 to the power of 4t. Are we still good? 40. No, not 40. 40. Anyways, from here, how do you get rid of that exponent?
Square root.
Nope. Square root is
Multiply by 1/4.
raised to the power of 1/4 might be what you
Yeah.
were saying, but what you say? Drop the base and switch. That's just a log function. So this is log base what?
3.2.
Ooh, the base is whatever carries the power. So it's log base 1.024 of what? 3.2 is equal to 4t. And find out what this is and divide by t, and you will get t is equal to approximately 17 years. Oh, I trusted you on that one.
I just didn't write a number.
Oh no, next time don't throw it random number. What do y'all get?
12.26.
It was too good to be true on this one. So t is approximately equal to 12.26
26.
years. And what I would do is I will box this as my first answer. Is it complicated? It's just plugging the form into the formula. Now, do you think it was a better idea, instead of compounding it quarterly, to compound it continuously? Let's figure out. Let's go ahead and use the continuously equation, meaning I will say A, which is 8,000, is equal to 2,500 e to the power of 0.095, that's 95 t. You understand which formula I'm using now, right? Now, we already know that once we divide these two, we get 3.2 is equal to e to the power of 0.095 t. Who would like to tell me what to do next? What was that? ln. You're not going to use log base e. You will call it ln. But ln of what? ln of 3.2 is equal to 0.095 t. And you will first end up dividing. So find out what this is and figure out what's the approximate value of t. Let's look at problem number 2. This time it says Jimmy's grandfather opens a saving account for him the day he was born, and he has a balance of 1,000. Does that represent the principal or not? A. P. If no withdrawals or deposits are made, how long will it take the amount to reach a balance of 20,000? So this one now represents my A. The account pays an annual interest of 6.2. That 6.2 is actually 0.062 compounded. We have continuously and monthly. Compounded monthly. Monthly means n is equal to 12. So let's go ahead and plug it into the equation. I will start by 20,000 is equal to 1,000. 1 plus 0.062 over 12 to the power of 12t. Easy so far, right? Now, if I divide both by 1,000, I will get 20 is equal to, who will give me this value? I'll need your calculator once you get the chance. So I got 1.005. I raised it to the power of 12t. So from here, what do I need? Log base 1.005 of 20 is equal to 12t. Now, maybe I need to show you how to put this on the calculator, because you do not want to round anything. Was this a rounded value? The 1.005. It was rounded? Okay. Look how I put this on my calculator. So I will start by alpha, window 5, and before that, it was 1 plus what? 0.0.
Zero.
0.062 divided by 12. And this is what I get. Now, when I do alpha window 5, the base, I will go back up and select it. Note that I put the whole thing. I do not round when putting on my calculator. Log base, all that of what? On this part paper was 20, and I press enter, and I will divide this value by 12. Sometimes it will give you something slightly different. Did it give you the same thing when you round it? Use the rounded value and see what it gives you. It's different. You get 600. You see how bad the difference can be. So you do not need to round. So it gave you 600 on this one, right? And when you divide it by 12, what you got? It's a big difference. So 48.44 is my final answer. I assume that you probably rounded also on the previous one. So T is approximately equal to 48.44. Let's do it continuously now. By the way, I'll pick back up at this level, meaning 20 is equal to e to the power of 0.062 t, and I will use the natural log. That means natural log of 20 is equal to 0.062 t, and t is therefore approximately equal to what? 48.32. They both in terms of years. Now, if it was your money, which account will you put your money into? I would definitely put it into continuously. You know why? Because you get to that amount of money quicker. You get to it quicker than this. Now, if it's a bacteria growing, you want to be on the monthly because it takes you longer to get to that amount of bacteria. Here we have other applications. Here we have the growth and decay. You are so familiar with this by now, right? The plus and minus. Because this is what we've been using over and over again. And growth and decay continuously remains the same, PERT. Now, 300 grams of radium is stored in a container. The amount of radium R in grams present after T years is given by R. Now, here the formula is given. How much of this will remain after 5,000 years? All you got to do is plug in the 5,000 for T, and you will get your answer. Now, I am not a fan of plugging numbers because I know this type of problem will always ask more than one question. What I do on my calculator is I plug in that equation on the y equal. So, on the y equal, I'll plug in that whole equation, which is 3000 e or 300 e to the power of negative 0.00443. Do I have enough zeros there? And what I do is, how do I find for 5,000? What's the quickest way to get to it? Second table set, and you request to start at 5,000 and go back to your table. It should start at 5,000 and it's at 34.945. So this is 34.945. And what's the unit? Is in grams. When would the amount of radium in the container reach 100 grams? What do I need to do? This 100 represent my Y2. So on the Y equal, I'll make sure I have 100 on the second portion. And I will do zoom what? Zoom 0. And it will graph both equations. Now, what happens if yours shows this? You will zoom, you would mess with I can mess with the window, or I can zoom out. Zoom out might take forever. Now, what is the blue line doing? Increasing or decreasing? What about the red? Constant. So I need to see more of my X's or more of my Y's? X, maybe more of my Y's too. So on the Y equal, or on my window, X minimum can stay there. X maximum, what do you want me to put?
100.
100 only? I go crazy 500. Y max is only at 300. I go 500 too. Oh, just 500. And I will graph it again. This is what I see now. Was 500 even good? I don't think 500 was good enough. So let's go super crazy on this. On the window, instead of 500, I go 50,000 and I'll graph it. That was very good, actually. So what I need to do is second trace 5. Enter. And it tells me that it's after how many years? 2554.91. 2554.91. Mariana is not here to request me to do it by hand, but I'll do it. So let's start with 100 is equal to 300 e to the power of negative 0.0043 t, right? Now I will divide both sides by 300 to get 1/3 is equal to e to the power of negative 0.000. I feel like I'm missing a zero here. 43t. I think there are a total of 4 zeros. Now from here I will use the Nash log, and I will say Nash log of 1/3 is equal to negative 0.00043 t, and I divide by this. So let's use our calculator to see if we get the same answer. So I will say Nash log of, I'll go ahead and even put a fraction there to put 1/3. And I will divide my final answer by negative 0.000. It was 43?
Yeah.
43. And I get 25554.912. Isn't that the exact same answer? So doing it by hand will give you partial credit. Doing it on the calculator and getting it wrong, good luck. You get all points off. All right, number 4, the amount of money. As soon as I see an equation, what comes in mind, put that on the Y equal. So let's go ahead and put that equation on the Y equal. That's 8, 6, 7, 9. I'll do the last one. In 1996, a new Mustang GT cost $16,500. Suppose that the car depreciate 24% each year. Depreciate, what does that mean? Is it going to be a... Oh, wow, they gave you already the equation. It's a minus when it depreciate. Normally, I will put plus and minus. It's your job to know that depreciate means minus, right? So, 16,500, what does that represent? That's your P. Estimate the value of the car in 2000. 2000 is T equals what? 1996 to 2000 is 4. But the first question is find the equation. So I will say S of T is equal to P, which is 16,500. Inside the parenthesis, I will have 1 minus 0.24 T, which can be simplified to 16,500. 1 minus 0.24 is 0.76 T. This equation is what you were looking for A. For B, you will just plug in 4 into it. Again, once I get the equation, I'll plug it into my calculator. So I want you to plug this into your calculator as well, my calculator froze and I shut it down. So plug into your calculator and tell me what you get. The 1000 as a Y2. Once you plug in 1000 of the Y2, you zoom 0, mess with your window if needed, second trace 5, enter, and get the answer. Any question? Good.